Section 5.2 is on properties of rectangles, rhombuses, and squares. The objectives for today are to classify a quadrilateral with the most specific name based on its properties. Then we're going to apply properties of specific parallelograms to find missing values. And we're going to identify the difference between rhombuses, squares, and rectangles. So in 5.1, we talked about how we have quadrilaterals and a type of quadrilateral is a parallelogram. Today, we're going to talk about the three types of parallelograms, which are the rectangles, rhombuses, and squares. So the first type is a rhombus. So a rhombus is a parallelogram. So those 5 properties that we talked about in a parallelogram are all true for rhombuses, which means they have opposite angles congruent and sides. The diagonals bisect each other. Consecutive angles are supplementary. Let's see, that's 1, 2, 3, 4. And it has 2 pairs of parallel lines. So all of those things are true for a rhombus. And then there's another part added onto this, which is that the 4 sides are all congruent. So we have 4 congruent sides. If we were to draw one, it would look like this, where all 4 sides are congruent to each other. And that is one type of parallelogram. The next one is a rectangle, which is also a parallelogram. The classifying characteristic of a rectangle would be that it has 4 right angles. So that would be a second type of parallelogram. And then the last type that we're going to talk about is a square. A square is a parallelogram which has 4 congruent sides and 4 right angles. Sorry about that. And you might notice that the 4 congruent sides is very similar. It has the same property as a rhombus. And then the 4 right angles, that is the same property of a rectangle. Which means that not only is it a type of parallelogram, it is also considered a rhombus and a rectangle. So at this diagram to the right that I've been writing out as we went over these, at the top we started with quadrilaterals. A specific type of quadrilateral is a parallelogram. And then from parallelogram, we know we have a rhombus or a rectangle based off of if the sides are congruent or if they have right angles. And then the most specific name we could give a parallelogram is a square if it has all congruent sides and 4 right angles. If it doesn't have those 4 congruent sides, then it's just a rectangle. If it doesn't have 4 right angles, then it is a rhombus. Knowing this chart will be useful, so drawing it down would be a good idea on your notes. Using this information, we are going to give the most specific names for the following parallelograms. So we know in a rectangle, it has all of the properties of a parallelogram and it has 4 right angles, which is what this one has. We know it can't be a rhombus because the side lengths aren't all the same, so that makes it a rectangle. If we look at example B, one thing you should notice is that all of the sides are the same length, so they are all congruent to each other. And that is true for a rhombus or a square. But if you notice, the angles are not right angles, so that is why the name for this one would be a rhombus. And the third one, C, we know the opposite sides are congruent to each other, but we don't have any right angles. So this one is just going to be a parallelogram. And we know it's a parallelogram because the opposite angles are congruent to each other. So we have these two 97s and then 83 and 83. So the most specific name we could give this one is a parallelogram. All right. The next one, we are going to state all possible names for this figure. So this one, it is a quadrilateral because it has 4 sides. Opposite sides are congruent to each other, so we know it's also a parallelogram. All of the sides are congruent to each other, so we know it's a rhombus. All 4 angles are right angles, so we also know it's a rectangle. And because it qualifies as both a rectangle and a rhombus, we know the most specific name for this would be a square. So if you were asked to give all possible names for this figure, we would give all 5 of these. If we're asked for the most specific name, your only answer that you would put is a square, because that's the most specific. It tells us all of the properties in just one word. Okay. Example 3 they give us is for any rhombus, QRST, decide whether the statement is always, sometimes, or never true. When you're not given an image, I always recommend drawing one out for yourself, and then filling in any information we know. And we know that a rhombus has 4 congruent sides. When you name a rhombus, it's very similar to how we would name a triangle, except the name has 4 points in it. When you're naming it, you always want to go in order around the shape for the order they're given to you. So we're going to start with Q, R, S, T. So they have to go in the same order as you're moving around the shape as the name they give you. So for this, they want to know sometimes, always, or never is angle Q congruent to angle S. Now because a rhombus is a parallelogram, we know opposite angles are congruent to each other, which would mean this one is always true. The next one, they want to know if angle Q is congruent to angle R. And for that one, they are consecutive angles, so we know they are supplementary to each other. And that means that sometimes they will be congruent to each other. And the only time they are going to be congruent to each other is if the rhombus is also a square. And that would make them both right angles. So that's when they would be congruent to each other. And that would be sometimes. A few properties that we are going to add to these for the theorems is a parallelogram is a rhombus. Oh, this should be if. If and only if its diagonals are perpendicular. So that means if you had a rhombus and you drew in the diagonals, they're going to be meeting at a right angle. So we have our first diagonal, our second one, right here is a right angle. Also, if a parallelogram is a rhombus, if and only if the diagonals bisect a pair of opposite angles. So what that means is, for example, this dark blue diagonal, if this shape is a rhombus, it is going to be cutting these two angles in half. And because we know the bigger angles are congruent to each other, if we're cutting them both in half, that means each smaller angle is going to be congruent to the other. The same thing is true for the other diagonal. The four angles that it forms are all going to be congruent to each other. So then the next one is about rectangles, and a parallelogram is a rectangle if and only if its diagonals are congruent. So because we know in a parallelogram that diagonals bisect each other, if these segments are congruent, the two red ones, we know each section is congruent to the other. So when you draw both diagonals in a rectangle, you form four congruent segments. Now we're going to use this information to complete a few examples. The first one, we are going to sketch a rectangle ABCD. So we're just going to have a rectangle, and we're going to go ahead and name it ABCD. We're going to label the diagram with everything we know about it. So in rectangles, we know opposite sides are congruent to each other. Another thing we know is that all four angles are right angles. And if we were to draw the diagonals in here, we know that those diagonals are congruent to each other. And that means that each little segment it forms are congruent to each other. So that is everything that we know. Oh, sorry. I guess we also know these lines are parallel with each other. Now that is everything that we know about our rectangle. Example 5, we are going to classify the quadrilateral with the most specific name possible and then find the value of the variables. So for this one, I guess it doesn't really give us much on here to classify it. But it is going to be a parallelogram. That's a rhombus and a square. So normally you're not supposed to assume, this is kind of a bad example, but we should have these four right angles in there and all of the sides marked congruent to each other. And then we would know from that information that this is a square. So knowing that, we can set up our two equations that we are going to use. The first thing we're going to have to do is we will have to solve for y. They give us more information than we need to get y. So we can choose any two of these and set them equal to each other. It doesn't matter which two, as long as you choose two of the expressions that have y in them. Then once you have that, you can go ahead and start solving your equation to get y by itself. Once you're done, you should get y equal to 4. Then we are going to use that information and plug it in. So over here we know y is 4 minus 2. That tells us this side length is equal to 2. Because all of the side lengths are congruent to each other, we can now set up an equation for x. So we know that 3x minus 4 is equal to 2. Then we can go ahead and solve. We'll get 3x equals 6, divide by 3. That tells us that x is equal to 2. So now we are done and we have solved for both of the variables. Our last example on here, example 7, is classify the quadrilateral with the most specific name possible. Then we're going to find the value of the variables. So this is the type of example that you're going to be getting. And for this, you can see clearly marked that we have all 4 sides are marked congruent to each other. And they also give us these symbols to tell us that these lines, opposite pair of sides, are parallel with each other. So the most specific name that we could give this parallelogram is a rhombus. Now, knowing that it is a rhombus, we can set up our equation knowing that the side lengths are equal to each other. And we can go ahead and start solving for x. And our final answer, we should get that x is equal to 5. With all of this information, you should be able to complete the exit ticket. Again, if you're doing this on paper, you can scan the QR code, and then if you're doing it on your virtual notes, you can click the link for the exit ticket. Once you're done with that, you can start the homework. The homework, there are a few problems on there that we haven't learned quite how to do yet, so you can skip questions 16, 20, and 24. We are going to learn how to do those in a different chapter, so for now we are just going to skip them. And if you have any questions, just let me know and have a good day.